Welcome to part 3 of Competency 18 of your TExES math exam. In this video, we will discuss deductive and inductive reasoning. Okay, for this part of Competency 18, we're focusing on mathematical reasoning in the aspects of deductive reasoning, inductive reasoning. Okay, for the deductive reasoning, this involves applying a generally accepted or proven theorem or formula to a specific example. That means if it's stated in generalities, and if you remember your professors talking like that, that means it's a blanket statement with variables that are unspecific, be that a verbal variable or like an actual, if you're dealing with a formula of X, Y, Z, okay? So even a theory, if it's written out and explained and no values are given to it, no example, then they have to follow that with a specific example. And unfortunately, that's a lot of what teaching has been historically, okay? Think of back if you're a little older, not more modern, but older, your teacher gave you the formula, then gave you examples how to work it, and then said, here's some more, you go solve them. Okay, now, inductive. This is a more modern idea of teaching. It uses specific examples in order to make a valid generalization. So they're going to give you some numbers and and then they're going to say, okay, what do you see on that pattern? Can you make a conjecture from the pattern you see? Sometimes we can, sometimes we can't. Okay, let's talk about number one. Actually, a little bit before number one, 2 points I want to make. One is, that's too far. One is for this competency, there is minimal TI-84 use, if you haven't noticed, but you need your TI-84 to double check numbers just in case, you get tired and you can't think through it. And then the next major point is you have to know your topics. Every question is asked in a way assuming that the beginning teacher understands the basics fully. So if anything comes up in any of these questions that you don't understand, oh, please, please, please go to the internet, find you someone you like, is reliable, and study that topic. Okay. Number one, for the following statements, which is an example of inductive reasoning. Okay, so we want inductive. What is inductive? Inductive is where you're given the example and then you make something you have a generalization or a statement in generalities, that looks more like a formula, or they're stating a formula. Okay, let's look here. Okay, A. Now, here's the thing. When you're taking a test, you can read these fully if you want. But for me, right now, I'm just trying to teach you. Time is of the essence. You have more studying to do. Okay, they are talking about in A, the Pythagorean theorem. Obviously, that's general. When they get any theorem is general, those words say, I'm beginning general. So let's go down here and check. Do they end in an example? Okay, they talk about the Pythagorean theorem that it says if A is 3 and B is 4, the right triangle then is is 5. Okay. And this is blatant example, giving you the numbers that plug into the formula. Okay, that is not inductive, that is deductive. They started with the formula. Let's read B. Any missing side of a right triangle can be solved using, okay, two key things. Any. Okay, and then they gave you a formula. That's starting from the general, very general. And then right after that, this is like almost repeating A. And then, okay, here's your general. And then they go to the example. Well, that's deductive again. Well, let's look at C then. Okay, C says if the legs and hypotenuse for three right triangles are, okay, well, then they give you some examples of numbers of, okay, these are all examples. There's no formula here. They're just saying these examples, meaning here's the legs, here's example of the legs. Okay, I see starting with examples here. With the hypotenuse equal to C. Now they're telling you in the example, here's your examples, and all these C's are called the hypotenuse. Then the hypotenuse must be the longest, let's look here, the longest side of all right triangles. Okay, the word all tells me general, general, general. So here are three specific examples with the numbers. There's a generality. I'm saying that is called inductive reasoning. But double check on D. All right. We're going to double check. Okay. They are saying that this looks familiar. The Pythagorean theorem is stated as, well, those are general letters. It's not specific numbers. Then it says if A is 8 and B is 15 and in a right triangle, then the hypotenuse must be, well, that is an example where it looks like they calculated it. But then they go back to the example. Well, they're trying to kind of fool you. What this is not the example going to the formula. This is, hey, my teacher gave me this formula right here. Okay, I went and took their word problem. So here's their problem, and they gave me these numbers. And then this right here is okay. I took it and worked it out. And then finally, this says, oh, well, I manipulated that generality. So you gave me a generality. I used an example to show it. Now I'm going to go back to the generality to prove that my example is correct. I wouldn't call that inductive reasoning. That would be called deductive because really you're just starting with the formula and manipulating the formula. Then you went and solved the example. Okay. No. What am I doing? We want to get rid of that. Okay. Number 2, given the following statements, in a given triangle ABC, measure angle C equals 90, measure angle A equals 44, and uh, measure angle B equals 46. In a given triangle DEF, measure angle F equals 90 degrees, measure angle D equals 30 degrees, and measure angle E equals 60 degrees. Is the claim the sum of the acute angles of any right triangle must be 90 degrees, deductive or inductive reasoning? Okay. Well, if you think about what we had talked about, the difference, deductive starts with the general and moves to an example. And inductive starts with the example. And then from that example, you look at the patterns and draw out a general conclusion. Well, I think inductive is exactly what we're seeing here. And it is. Obviously, these statements are examples of triangles. And the fact that it says given here, and then you go down to your conclusion or claim, it says any. Well, there's many, many right triangles, so that's definitely general. Okay, let's go to notice again. We didn't look at our calculator. Not everything can be solved with a calculator. Okay. In the statement below, deductive or in sorry, is the statement below deductive or inductive reasoning? It'd help if I could read today. Whenever equals are added to equals, the results are equal. Okay, that is clumsy, but it is math talk. And just think about it. Are there any numbers in there? No. Is there further example? No. That is a general blanket statement. Clumsy, but correctly written, and it is correct. Now they go and they say, given that. And this is what this whole statement means. Given that M equals N, okay? These are the equals. So they're starting with a general. Now they're going to give you a true example. This is really the example part right here. This is your example. So obviously, this is deductive reasoning. They began with a general statement, gave you sort of a general meaning, and actually, they could have been more general than that, by saying A equals 5. But this is obviously an example. So we could give values to M and N. We could say that M equals N equals 4. Then both these statements would equal. However you want to justify it to yourself. Okay, number 4. Is the statement below deductive or inductive reasoning? Okay. The product of two odd integers is an odd integer. Well, that's general. There's no numbers there. There's no examples. And then they go to the specific. Okay. Generally, if we are given the numbers 7 and 9, their products must be odd. Okay. And you can, that's where it's one of those things where now you can put it, if they give you larger, more in-depth numbers, you could start crunching this to check, if it was some other general claim that was a little more in depth, which could happen, but you're supposed to know how to do these things. So obviously, we see that that's odd. And you could try other things for your example. So they are starting with a generality and going to the example and where you could do your own examples. So that is deductive again. Number 5. Given the three equations, 5 times 8 equals 40, 10 times 3 equals 30, and 11 times 12 equals 32, it would be nearly impossible to determine which statement would represent the conclusion. I agree with that. One statement could be the product of an odd integer and an even integer is always even. Okay, I agree with all that. That makes sense because there's infinitely many uh, integers involved, and everything there you see is positive. Yeah, there could be, I could see a lot of conclusions if you want to say, well, it has to be natural numbers, not necessarily. Doesn't matter. A lot can be said and thought about this. The point is, we began with an example. That's an example. And what did we end it with? A general conclusion from a given example is what? Inductive reasoning. Okay, looks like I have a typo. Ah, easily fixed. Not a problem. Number 6. Oh, let's scoot up first. Scoot up so we can see it. Okay. Number 6. The square root of the sum of two positive numbers is less than the sum of the square roots of these two numbers. Thus, if 5 and 6 are the given numbers, this is what they have here. Okay, first off, I just want to say I see beginning with general. I'm going to get my, this is all a general statement. Then they give you some numbers where you can go try out the example. Okay. So, let's try out for grins. We know this is deductive. Okay, because we can take and plug in numbers and test that out. Okay, so let's do that. Let's give that a go. All right, let's see. 5 plus 6. All right, push enter. Okay. And then let's see. They're saying that would be less. So let's add the other two together. Second square root 5. Remember to arrow over. Push your plus. Second square root 6. Arrow over. Okay, let's see if that should be greater. And it is. That proven. I'm not going to spend time doing that, but if you haven't played with these numbers and these these conclusions, go for it. Okay, we just don't have time to do all that. Okay, number 7. In an equilateral triangle with sides S, the area is given by the equation, okay, S squared over 4 times square root of 3. Okay, thus, if we are given an equilateral triangle whose sides is 6, the area must be 6 squared divided by 4 times square root of 3. Okay, now that is for some of us, we may say, well, that's an example they gave us because it's an equation. No. An equation, a formula, that's a formula because it has that unknown variable in it. So they are starting from the general, and this whole statement, this blanket statement, it's general. We really can't plug anything in yet until they come over here and give us that 6. And then we could solve. And then we could put any number in and get, oh, another thing. Remember I said you got to know your properties? Well, you have to know what an equilateral triangle is. Hopefully that you're at the point in your studies where you remember all the names of the triangles and all the properties of the triangles. If you don't, you're a little shaky. Please go out there and brush up. Okay. Like I said, lots of good videos out there. Pick somebody and use them and do some studying. Okay. So that is general to this is our example. That is deductive. And this is the end of this particular video. We will have another section. We have one more section to cover in Competency 18. However, the next section will be regression. And what I'm going to do is cover regression very thoroughly and where the mathematical reasoning comes into play with it. No fear, it's a big topic. If you're a little shaky, we are going to use the TI-84 extensively, and it will branch out into other competencies. Okay, I thank you so much for watching. And if you like these videos, give us a thumbs up and please consider subscribing.